So this question is taking you through a titration, which is a neutralization reaction to produce a salt, and we're reacting hydrochloric acid with potassium hydroxide. They're describing here how the student carried out the titration, and then they've outlined the first 5 steps, but these steps are not in the right order. So what they want us to do is to get them into the correct order. So they're telling us here that the first step is K. So K says, let's get rid of K, but K says fill the burette with hydrochloric acid and record the initial volume from the burette. If we now look down the line of other steps we need to include, we see this second step here is we now need to measure out the potassium hydroxide. So that would be step L. We're going to use a pipette to measure out the 25 centimeters cubed of the potassium hydroxide. And then we need to put that potassium hydroxide into a conical flask with indicator. So that's step J. Put that into the flask. And then what we now start to do is we start to add the acid to the alkali. So that's described in step N. And then M is done for us. We take the reading at the end to look at how much volume we have added. 1 mark, get them in the right order, you get the mark. Suggest an alternative piece of apparatus that could be used in step L to exactly measure out. Let's look at in step L, they've actually used a measuring cylinder. If you remember when we did this in class, we actually used a pipette because that's a far more accurate way of measuring the volume. It then says the student was asked to produce a pure sample, key part of that, pure sample of this salt. So after finding the volume reacted, the student added its volume for a fresh sample. The mixture was then evaporated. Explain why the new mixture, rather than the original mixture, was evaporated. So the original mixture contained the indicator. So the original solution contained indicator. And if you evaporated that, then your salt would contain the indicator. So this would mean the salt was contaminated by the indicator. If you did, you could argue that the second one doesn't contain an indicator and therefore the salt is pure. So either way, 1 mark for each statement we have made there. Okay, we then got that after evaporation, the mass was determined. The theoretical, so that's what they should have made according to the balanced equation, is 0.7, but they actually made more than that. Now we know they can't make more than that because the law of conservation mass says mass cannot be created or destroyed. So why would the percentage be greater than 100? This must be because during the evaporation process, it must still be damp, and therefore it's given us more. But it wants us to calculate the percentage yield to show it's greater than 100%. So all we've got to do here is 0.84 divided by the 0.7. So this is what we got divided by what we could have got, times by 100. Let me just start on my calculator. So 0.84 divided by 0.7 times that by 100, and I'm getting 120%. Marks wise, 1 mark for those 2 bits. I suggest why it's more. This is because the final yield will have been wet, as all the water was not evaporated. Okay, and last little bit, we now got to calculate atom economy. So here's my equation. It's the mass of desired product divided by the total mass of all products. So it tells us here, calculate the atom economy for potassium chloride. So this is my desired product, and the mass of potassium chloride is 74.5. and then we're going to divide that by the mass of all products. So it's 74.5 plus, we've also got water, which is 18, and then we times all that by 100. So let's just do that on my calculator. 74.5 divided by 74.5 plus 18, and that's going to give me an answer of 80.5405, but here it wants to go to one decimal place, so one decimal place, looking at this, is therefore going to be 80.5. Marks wise, there are 4 marks. You get a mark for doing this part, a mark in here for doing this, and then this, and then a mark for getting that part there as well. So 4 marks in total.